Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family in the best of health. Dear students, this lecture is for grade 7, boys and girls both wings, subject science. And in this lecture, we are going to start chapter number 11, which is about circuits and electric current. This is my 29th lecture, and I am your lecturer, Mrs. Saira Jamal. Electricity. Dear students, we have learned in grade 6 that electricity supplies us energy. Electricity can produce light, heat, sound, etc. Electrical energy can help make our lives easier, and we have learned that there are two kinds of electricity: static electricity and electric current. What is static electricity? The electricity produced by friction is called static electricity. The detail about static electricity you have learned in the previous classes. Here we shall discuss electric current and its effects and measurements. Flow of current, or what is the direction of current to flow? The flow of charges. What is current? The flow of charges through a conductor is called electric current. What is electric current? The flow of charges through a conductor is called electric current. What is conductor? A material which allows the electric current to pass through it is called conductor. So the flow of charges through that material which allows the current to pass through it is called electric current. Charges travel or current travel from one pole to other pole of an electrical source. What is electrical source? Battery. As battery provides electricity to the conductor, so battery is the source. Charges travel from one pole of a battery to another pole of a battery. So this is called electric current. It has been proved that only negatively charged electrons move from one place to the other. It means that the flow of charges, the charges here means negatively charged electrons. And actually the negatively charged electrons move from one place to the other. Positively charged protons do not move. You can see in this image the electrons that they are moving from the negative terminal of a battery to the positive terminal of a battery. The positive charges remain at their position. They have the same position, they are not changing their places, but only the electrons or the negatively charges, they are moving in through the conductor, or they are moving or they are passing from one atom of the conductor to another atom of the conductor. In early days before the discovery of electrons, scientists guessed wrongly that electric current was the flow of positive charges from the positive pole of the battery to the negative pole. Scientists still adopt this idea and they have called it as conventional current. What is the unit of electric current? The unit of electric current is ampere and it is represented with a capital A. Other small units are milliampere, which is represented as small m and capital A, and microampere with a micro symbol and capital A. Electric current is measured by an instrument or with the help of an instrument which is called ammeter. What is the name of that instrument? Ammeter. An electric circuit is a complete path along which charges flow. Electric current only flows through a closed circuit. I am sure that we have learned it in the previous classes about the closed circuit and open circuit. When we turn on the switch, the circuit is completed and it is called closed circuit. When we turn off the switch or the button, the circuit is incomplete and it is called open circuit. Conductors and insulators. As I told you, the materials which allow electric current to pass through them are called conductors. All metals such as copper, silver, iron, and aluminium are good conductors. And the materials which do not conduct electricity to pass through them are called insulators. For example, rubber, glass, sand, plastic, and wood are the examples of insulator. What happened if we use conductor in a circuit? Suppose if this is a metallic slab which we are using in a circuit, or if we are using in this case is a metallic slab, and in this case we are using a wooden slab or insulator wooden slab, or a rubber or a glass slab, or even a plastic slab. If we use in an electric circuit, you can see that in this case the circuit is completed, because this material will allow the current to pass through it, and then the current will flow from the one terminal of the battery or one pole of a battery to another pole, and then in turn the circuit is complete circuit and current will flow and the bulb will lit up. But in this case, if the slab is made of plastic, glass, rubber, wood, or sand, then what will happen? The circuit will not complete it, because the slab will not allow the current to pass through it. Thus, in turn, the circuit will be incomplete circuit. It is called open circuit, and the bulb will not lit up. Types of electric circuits. There are two types of electric circuit, although there are many types, several types, but here we shall discuss its two important types: series circuit and parallel circuit. What is series circuit? If all the components are connected one after another in a single loop, all the components, you can see the bulbs, the battery, and the switch, even the electric wires, all are connected in a single loop. You can see this is loop, and this all the components, they are connected in a single loop. Then this type of circuit is called series circuit. In a series circuit, there is only one path for the current to flow, and the amount of current which flows through each component, means bulb of the circuit, is the same. You can see the amount of current which flows through this single loop, it will be same for this bulb and same for this bulb. Disadvantages of the series circuit. There is a disadvantage of the series circuit. What is that disadvantage? There is only one path for the current to flow. You can see for the current to flow, there is a single path, and a break at any part of the circuit stops the flow of current in the whole circuit. You can see that a break in any part, like if we remove this bulb, you can see all the bulbs turn off, all the bulbs will turn off. The reason is that any break at any point in the series circuit will stop current flowing in the complete series circuit. So by removing only one bulb, you can see all the bulbs will turn off. Second type of circuit is parallel circuit. If the components are connected in two or more loops, or you can see branches in this case. So you can see here, this is one loop and this one is the second loop. So if the components are connected in more than one loop, or if there are branches in the circuit, then it is called parallel circuit. In a parallel circuit, there are more than one path for the current to flow. For the current to flow, this is one of the path and this is another path. So there are, you can see these, the flow of current, these red current which is passing in two ways. This is the first path and that is the second path for the current to flow. So if the components are connected in two or more loops, and a second thing, in a parallel circuit there are more than one path for the current to flow. The current flowing through different branches of a parallel circuit may be the same, or different. The current may be different or same, but the current in each branch is less than the total current flowing out from the electrical sources, because the current which comes out from the electrical source, it divides in two branches. So definitely the total current is, suppose if it is suppose if it is 4 volt, then 2 volt current will pass through this loop, and 2 volt to the second loop. So the current will divide, and the current passing through each loop will be lesser than the total current produced by this battery. What is the advantage of a parallel circuit over a series circuit? Parallel circuit has an advantage over a series circuit. There are more than one path for the current to flow. A break in any branch of the circuit stops the current flowing through that branch only. You can see here, by removing one bulb, only the current flowing stop at this branch, while the current or the bulb at the other branches will lit up, it will remain lit up, nothing will happen to them. It means that if one of the bulb is removed in this branch, so only the current will stop flowing through this branch. At the other branches, the current will continue to flow. Extend your thinking. Why electrical wiring in our houses is parallel rather than in series circuit? The reason is same, which I told you, because if any appliance in our home, it get damaged or current will not pass through them, then the current will pass through the another circuits easily. Suppose if there is a problem in electrical wiring in one room, so the bulbs and the lights will lit up in the other rooms. Nothing will happen to the light or to the bulbs in other rooms. Only that room will affected, which has problem in wiring. So parallel circuit is best than the series circuit. Energy transfer in electrical circuit. Electricity brings energy to our homes, and from where that electricity come? Electricity comes from the power station. The power station actually supply electricity to us. The energy of moving electrical charges within a circuit is called electrical energy. The energy of moving charges, I told you what is electricity. Electricity is the flow of charge. What is electrical energy? The energy of moving charges. The energy of those charges which are moving is called electrical energy. As charges flow in a circuit, some electrical energy always changes to heat energy. Yes, if you touch an electrical bulb, you will feel that it is too hot. It means that electrical energy is converted into light energy as well as heat energy. Light bulb transforms electrical energy to light energy as well as heat energy. Electrical bulbs, bells and stereo players transform electrical energy to sound energy. A heater gives us heat by using electrical energy, and a fan converts electrical energy into mechanical energy. So it means that electrical energy can be converted into different forms of energy. That may be light energy, sound energy, mechanical energy. So the electrical energy can be converted into different forms of energy. How do charges flow? The flow of electrons through a conductor can be compared to the flow of water in a pipe. In order to understand the flow of charges in a conductor, let us take the example of water or the flow of water. You can see here there are two canes, and connect the two canes of water with through a pipe. You can see one cane of the water, you have to place it on the table, and the second container you have to place it on the floor. What will happen to the flow of water? The water flows from the higher level to the lower level. It's understood that the water will flow from the higher container toward the lower container. So the potential energy of water in the can at a higher level causes the water to flow. Similarly, current flows like same like the flow of water. Current flows from the higher electrical potential to the lower electrical potential. You can see negatively charges are on greater percentage in this case, and they will move from the higher potential towards the lower potential. The electrons will move from the higher potential or the higher potential to the lower potential. You can see here that the first element having higher potential and the second element having lower potential. What will happen? The charges will flow or the electron will flow from the higher potential to the lower potential. So this is called voltage difference or a potential difference. The difference of potential between 2 points in a circuit or a battery is difference, electrical difference, or we also call it voltage. The difference in potential between 2 points is called voltage. Potential difference causes the charges to move through a conductor. Potential difference is measured in a unit called volts. Charges will flow as compared as there is a potential difference between the 2 points. Every battery has its own potential difference and it is printed on it. For example, a dry cell carries 1.5 volt and other units of volts are millivolts and kilovolts. And the instrument which is used to measure the potential difference is called voltmeter, which you can see in this image. Resistance. Electric current flows through some things better than through others. The measurement of how well something conducts electricity is its resistance. What is resistance? Resistance is the hindrance to the flow of current. During its journey through an electric circuit, the current collides countless times with atoms within the electric conductor, and these collision results in the hindrance to the movement of the current, which is called resistance. You can consider the smoke as electric current, and when it is flowing, it is colliding with the atoms of the conductor. You can consider this black cube as the atom of conductor. So if there is lesser collision between the charges and the atoms of the conductor, then we can say that this material has least resistance. But if there is more collision of the charges and the atoms of the conductor, then we can say that it has more resistance, or this conductor is showing more resistance to the flow of the current because of more collision with the charges. More collision with the charges, greater resistance, and less collision with the charges of the with the atoms of the conductor, then least resistance. The resistance of a wire depend on the length and thickness of the wire. So you can see that if we have a wide, long, if we have a wide tube and we have a narrow tube, so definitely the water will flow easily through the wide tube as compared to the narrow tube. The resistance of a wire depends on length of the wire and thickness of the wire. Recall the flow of water in a pipe. You can see here we have two pipes, wide pipes and the narrow pipe or thin pipe. Definitely the water will flow easily through the wide pipe as compared to the narrow pipe. So a long pipe, and one more thing is that if the pipe is too long, it will show more resistance as compared to the short pipe. So a long pipe resists the flow of water more than a short pipe, and a thin pipe resists the flow of water more than a wide pipe. So long wires have more resistance than short wires. Thin wires have more resistance than thick wire. Same like the water pipe, the electrical, the conductors or the electrical wires, they show the same factors, or they are affected by the same problems like the length of the wire and the thickness of the wire. Relationship between voltage and resistance. A mathematical equation shows the relationship between voltage and resistance. What is that mathematical relationship? Resistance is equal to voltage over current. It means that resistance has direct relationship with the voltage and inverse relationship with the current. The above equation shows that resistance is equal to the voltage divided by the current. It is called Ohm's law, a law represented by scientist Ohm. In 1827, a German scientist, George Simon Ohm, discovered the relationship between the voltage and resistance in an electric circuit. You can see here that there are more batteries, one, two, three batteries in this electrical circuit. So more batteries means that it will produces more current. More batteries, more voltage, then more current. More voltage, more current, more voltage. And in the second case, you can see there are two bulbs. Two bulbs means that we increase the resistance because the bulb have a wire which is called the filament, and that filament will act as a resistance, or they will produce resistance. So two bulb in a circuit means we increase the resistance in a circuit. More resistance means that it will produce less current, as due to which the bulb will lit up dimly. You can see here the bulb give us dim light. The reason is more resistance. More resistance means less current. Do you know that when electric current flows through the tungsten filament, the filament I told you, which is connected in the bulb, or which is sealed in a bulb, the resistance make the filament very hot, and that filament will act as a resistance, and it will make the bulb very hot. It is because of the high resistance of the tungsten filament that make it to glow. How could we measure the current, voltage, and resistance? We have three important devices through which we can measure the current, voltage, and resistance. First of all, an ammeter. Ammeter, I told you, represents with a capital A, ampere. So is the device to measure the amount of current in an electric circuit. It is connected to the circuit in series, so the full current passes through it. An ammeter does not change the amount of the current in a circuit because it has very low resistance. It only tells us about the value of the current, or the amount of current which flows through the circuit. Then voltmeter. Voltmeter, this is voltmeter which measure the current in volts, the potential difference in volts. A voltmeter is the device to measure the voltage or potential difference in a circuit. It is connected in parallel with the circuit, and the current does not flow through a voltmeter because it has very high resistance. Ammeter has very low resistance, and voltmeter has very high resistance. Multimeter can measure resistance, voltage, and currents, all three in one. Multimeter can measure voltage as well as the resistance and the current. You can see multimeter in this image. All electrical devices such as fans, blenders, computer, etc., they convert electrical energy into other forms of energy. Electrical power is the rate at which a device converts electrical energy into another form of energy. So that rate is called electric power. And its unit is in watt, or the bigger unit is kilowatt, kilowatt hour. And our electricity bill, it shows the amount of energy we use during 1 month, and it is taken as kilowatt. You can see in this image kWh, which shows kilowatt hour. 1 kilowatt hour is 1 unit on the electricity meter. You can also see here in this column, you can see units. So this unit of electricity means that electricity in 1 kilowatt per hour. 1 kilowatt hour is the amount of energy used up when an electrical appliance, any electrical appliance, use 1000 watt works for 1 hour per hour. The watt use per hour is called how much watt? 1000 watt works for 1 hour is called 1 kilo. Kilo, you know, it means that 1000 watt. Kilowatt means 1000 watt. An hour per hour. So dear student, hope you understand this lecture. It was all about the electricity, electric current, how to measure it, what is the unit, and inshallah the remaining topic we will discuss in our next lecture. Till then, best of luck, take care, Allah.